everyone, welcome back to Padhai Logic. Alright family, we have officially arrived at the final frontier, that is Unit 4. Give yourself a massive pat on the back for pushing this far. Let me tell you straight out of the gate, Unit 4 is an absolute gold mine for easy marks. Why? Because it's purely theoretical and definition based. So you will learn the concept easily and you'll secure full marks if you are able to understand the concept. So let's map out our final master roadmap of 8 high probability past year questions that we are going to destroy in this section. First is we will be unpacking what are the credit card frauds. Then we'll analyze the social network platforms and mobile platform security concern, and also deconstructing the digital certificates, digital signatures, and we'll write the short note on types of encryption, that is asymmetric and symmetric. Then we'll talk about what it means to secure a channel, and also we'll write the short note on SSL, cybercrimes, and VPN. We'll also discuss how spoofing threaten the platform availability, and while discussing cryptography and digital signature, we'll also write a short note on firewalls, proxy servers, and internet or intranet. So let's kick off things with starting with the first very major concept of Unit 4, that is major security threats in e-commerce. So this can come as a big marker asking for stating all the major security threats in e-commerce, or there can be a specific type of concern that might be asked in your exam. So first is the cyber crime and identity fraud. So in your exam, define identity fraud as the criminal acquisition and unauthorized use of victims' personal identifiable information like their name, social security number, or credit card details to commit the financial crime. So to maximize your score, what we'll do, we will state the issues first, right? And alongside we'll also state the solutions. So what are the core issues? First is account takeover. So what the attackers do, they use the credential stuffing or phishing to hijack a customer's legitimate profile on a storefront. For example, on a storefront like Electro Hub we were talking about. So what the attacker would do, the attacker would hijack the customer's profile, and it will drain the stored credit or loyalty points of the customer. All right, and then there is new account fraud. So it is new account fraud is done using stolen IDs to open fraudulent lines of stored credit. Alright, and there is data harvesting, in which the stacking and selling of massive databases, right, of stolen identities on dark web. That is called data harvesting. So attackers, they first store all the hijacked and stolen identities, and then they sell it on the dark web. And you see there is social engineering, in which they are tricking users into revealing their own password via high pressure manipulation tactics. Sometimes you receive a call in which they are manipulating you to write down something or click on particular link or open a particular tab. That is social engineering. Then you have financial loss, where there is direct financial loss which is wiping out the customer's linked banking assets. So you click on something, or you don't even click on something, there is directly money deducted from your bank, right? And then there is reputational damage, in which we are destroying a brand's consumer trust profile overnight. All right, so what can be the solution to this? The very first thing is we can enforce the mandatory multi-factor authentication and implement digital tokenization so that the actual card profiles are never exposed. Alright, so now let's pivot to credit card frauds. So this is the single most common crime in the online e-commerce platform. So this primarily occurs as CNP. Okay, this primarily occurs as CNP, or we can call it card not present fraud, where the attacker doesn't need physical plastic card. The physical plastic card is not required. They just use the stolen numbers over the web. So imagine an attacker using automated software bots to run card cracking attacks. So they buy a list of leaked card numbers from the dark web and use the bots to rapidly guess the missing expiry dates and 3-digit CVV code by making thousands of micro purchases across sites simultaneously. And this is a massive example of how credit card fraud happens. Alright, so this is the what I talked about. Then there is charge fraud, where the customer buy an item and then falsely claim they never received to get the refund. Right, and there is skimming as well, where we are capturing card data during the transaction process. Then we have refund fraud, where we are diverting a legitimate refund to a different fraudulent account. So refund has been initiated from our storefront, but it never receives the customer's bank account. Right, so this is where in between that refund fraud happens. And there is database breaches, where the direct theft of thousands of card records from a merchant server. For example, from ElectroHub website, we are storing the information of all the credit card details, and there is an attacker which fraudulently stores or stole all the credit card details and then sell it on the dark web. So what are the solutions to this? So there is a strict adherence to PCI DSS compliance, and we studied about what that is, and mandating the 3D secure protocols like verified by Visa or MasterCard identity check, which force an instant OTP authentication. And this OTP authentication check at the bank level before any cash can clear. So these are the solutions which can be applied to credit card frauds. Next is the spoofing and sniffing. So if we talk about spoofing, think of a packet sniffing as a digital wiretap. So if an e-commerce site is running on a basic unencrypted HTTP connection, any hacker sitting on the same network can intercept the data packets which are traveling through the air and read plain text credit card numbers and password using free sniffing software. Okay, so what you are doing, whenever something is traveling, the card details are traveling in a form of packets. So right, and this sniffing, what it does is it goes on the network and just very silently stole all the credit card numbers and password. Whereas spoofing, on the other hand, is all about deception. So for example, an attacker build an exact visual replica of our store but host it on a deceptive URL. So URL is something, replacing it with O with 0 or something like that, which you cannot able to identify that it is fake. So they send out then fake emails, right? So this is email spoof. This is what a website spoofing is. Okay, so you are decepting, you are creating fake things. And then what is email spoofing? Like we are stating a email, we are sending out fake email that your account is logged, click here to log in and confirm your password. So what is this? People would unsuspect these type of emails, right? Because it is coming from the bank, but it is not coming from the bank. It is actually faked, it is actually decepted, so that we never know that it is not from the bank, right? And you see, they are handling full account access. When we fill the login in such scenarios, we are giving the access to straight to the attacker, and they are able to access all the credential of our bank accounts. So this is the difference between sniffing and spoofing. So what are the solutions to this? You see, we have to have a mandatory use of SSL and TLS certificate to force an encrypted HTTPS connection, alongside implementing SPF and DMARC email verification protocols to block spoofed domain. Alright, so this is how we are able to handle these kind of scenarios. So, but what happens when an attacker doesn't want to steal data but simply wants to take your business completely offline? Okay, so in this scenario, they launch a DOS or DDoS attack. Alright, so DOS is denial of service, okay, and DDoS is distributed denial of service. So what happened in DDoS attack? These attacks aim to shut down an e-commerce presence. Okay, so the criminal takes control of thousands of infected computers or smart IoT devices across the globe, turning them into a coordinated zombie network, which is known as botnet. And at a specific command, these botnet floods your web server with millions of fake search requests simultaneously. Okay, so this what this does is, think of an example like cramming 50,000 fake shoppers into a local physical store. What happens if you see that in a particular store in your shop there are 50,000 fake shoppers? They don't want to buy anything, but they're just overcrowding things. So what happened that the legitimate buyers which actually want to buy among those 50,000, they can't even get through the front door. So the web and database servers run out of processing power, right? In this scenario, and they'll crash completely. And this will cause an immediate revenue loss and severe damage to your organic search engine rankings. So this is how the DOS and DDoS attack works. And what are the solutions to this? Solution is to host your platform with robust cloud computing providers like AWS or Azure that offer native automated edge DDoS protection and use an intelligent load balancer. Okay, they use an load balancer concept to drop the malicious bot traffic before it touches your server layer. So it acts as a wall which drops if there is any malicious activity identified, that no, this is not the actual server. If there are 10,000, 50,000 coming at one time, obviously they would identify it and it will send it back before even it comes to the server layer. As social commerce and m-commerce skyrocket, hackers have shifted their attention from old desktop computers straight to our phones. Why? Because our phones contain your entire life, your biometrics, your location, your banking apps, and your shipping profiles. So let's look at the vulnerabilities that keep data analysts up at night and exactly how engineer solutions against them. So social network and mobile network issues have introduced a unique vulnerability. First is the fake views. So attackers deploy coordinate botnets to flood the product page with thousands of artificial 5-star reviews to trick the buyer into purchasing low quality and non-existent items. Then there is phishing via social media. A user receives a direct message from Instagram that look exactly like a customer service alert from a major store saying that you won a free upgrade, click this link to claim. So the second they click, a malicious script harvests their payment credential. And then there are insecure mobile apps that are poorly coded retail application, and they often store users access tokens or plain text credential right inside the device's local cache instead of an isolated database. So if a malware slips onto the phone, it can scrape the data instantly. And there is app cloning, where the hackers download the merchant's authentic app, right, and they inject the malicious data sniffing code into the background and package it up and upload it to a shady third party app store as an imposter app to harvest user details. And you see there are public Wi-Fi vulnerabilities as well. So when a customer logs onto a free unencrypted airport, or for example Wi-Fi of a cafe, to buy an item, any bad actor sitting on that same network can use a basic network sniffer to capture their unencrypted transactional data right out of the air. And then there is a permission abuse, where simple clothing retail app, for example, request the permanent access to your device's microphone, to your contact list, to your photo gallery. So if that app's database gets breached, your private personal files are also exposed to the world. So let's do a quick reality check. That pause this video right now and open your smartphone setting panel. Look at your active app permissions and ask yourself, why does a basic shopping delivery app need 24/7 access to your microphone or your calendar? So if it doesn't, then turn it off, right? It is very important to maintain your privacy in your mobile phone and ensure that there is no not required information shared to such apps which are a little shady, or which does not require that particular information. So what are the engineering solutions? So to safeguard the mobile transaction system, we must ensure biometric authentication like Apple's Face ID or Android's fingerprint API to ensure that a transaction can only close if the physical owner is present. Right. And on the backend side, developers must conduct a regular automated application security audits and use the code obfuscation tools to scramble their raw source code, and making it incredibly difficult for the malicious actors to reverse engineer or clone the app. So this can prevent all the security level attacks which are happening on the data. Next we'll talk about is the cloud security issues. So remember our case study store ElectroHub? Like almost every modern enterprise, it doesn't own a physical server rack in a local basement. It runs entirely on cloud via networks like AWS, Google Cloud, or Microsoft Azure. But moving to the cloud means your data layer is now managed remotely. So this introduces unique structural vulnerabilities as well. So first is misconfigured storage buckets. This is a number one cause of massive data leaks in cloud history. An engineer accidentally changes the storage bucket configure setting from private to public, leaving millions of raw customer order invoices and credit history completely exposed to anyone with the URL link. Then there might be insecure APIs. So if a merchant plugs an external shipping or marketing tool into their cloud backend using an unvetted or poorly authenticated API link, the hackers can easily exploit that, lose connection, and gain unauthorized access to the core data layer. And then comes the shared technology vulnerability. So cloud computing is built on multi-tenancy, meaning multiple completely different corporate platforms share the exact same physical underlying hardware. So if a flaw exists at any bare metal level, a breach in one tenant's environment could theoretically compromise the neighboring data container as well, right? And then we have data loss. So running an enterprise store without automated cross-region redundant database backs up means that a single accidental deletion script can instantly wipe out your entire historical product catalog and your transaction data forever. So this is the irreversible data loss. Then there is lack of visibility as well. So in a massive complex cloud structure, monitoring precisely who and which service or which automated script is accessing sensitive customer directory can become incredibly different when there is no centralized logging. And malicious or malicious employee within your own company or within the cloud provider staff can abuse their valid admin privileges as well to scrape or compromise the sensitive data assets. So, what are the solutions to this? So, to neutralize these threats, cloud engineer enforce the strict principle of least privilege. Strict principle of least privilege. So, this rule dictates that no employee, no application, or any kind of script get full root admin access by default. They are granted only the absolute minimum access required to do their job. Furthermore, platforms use physical hardware security modules, which are specialized, which are highly secure hardware chip inside the cloud network to manage and isolate cryptographic encryption keys, ensuring that even if the data block are leaked, they remain completely unreadable ciphertext. Now let's shift our gear into a guaranteed high scoring topic that frequently anchors major exam question, that is what is encryption strategy. So if an examiner asks how we protect the data layer from network sniffing and spoofing, encryption is your ultimate shield. Okay, it is the core defense. Encryption is a mathematical process of transforming plain text into completely unreadable text, that is known as ciphertext. Alright, using advanced algorithm. So there are two types of encryption. First is symmetric encryption and there is asymmetric encryption. So if we talk about symmetric information, it is also known as secret key encryption. So it uses a single identical shared key to both lock and unlock the data payload. Okay, so there will be only one key that would be used for encrypting the data as well as decrypting the data. So it is exceptionally fast and lightweight and it requires minimal computing overhead. Alright, so the advantages and disadvantages would be, the biggest weakness is that how to share the key securely. So if a hacker sniffs the key during the transfer, the entire system is compromised. So the common algorithm used is advanced encryption standard. And if we talk about public key encryption, the asymmetric type, it solves the key distribution problem using a pair of keys. So here there is not only one key used, we use two keys, that is one visible public key and one is the hidden key. Okay, one is the hidden key, the private key, which is kept secret by the owner. So this is computationally heavy and it is slower than encryption, but you will see that it securely initializes public connection and distributing key across internet links, and you never have to share your secret key with anyone. So if you want to send the secure payment to Amazon, you encrypt the data using Amazon public key, and once it is encrypted, only Amazon's private key can decrypt it. So even if you cannot undo the encryption once it is sent. Alright, so it is more secure version since we are not sharing our private key with anyone. So the common algorithm used in this is RSA, which is reversed Shamir and admin. RSA. So you see over here, this is the sender, right? Sender is sending hello. It is encrypted into something ciphertext, and then by the receiver it is decrypted by using the private key. Alright, so this is the public private key exchange, how it happens. Then we'll talk about digital certificates. Now, how do encryption work together in the real world to verify, identify and stop website spoofing? So they form digital certificates and digital signatures running inside the public key infrastructure framework. Okay, so what is digital certificate? It acts like an official digital passport for a website. It is verified and issued by an independent, trusted global entity which is known as CA, or we can say certified authority like DigiCert or Let's Encrypt. So you see, a digital signature is a stamp which is used to verify the absolute authenticity and integrity of a digital transaction, and it provide non-repudiation, meaning a sender cannot falsely claim that they didn't authorize a purchase, because only their unique private key could have guaranteed that cryptographic signature stamp. And like I told you, this certificate would be like a digital passport for the website, right? So let's do an example check. So look at the top corner of your web browser right now, on any secure site. Do you see that little padlock icon next to the URL address? You can click it. When you click it, the browser displays a notification saying that connection is secure. And if you click deeper into the connection detail, it reveals the explicit digital certificate which is issued to that domain, and it showcases the site owner name, public key, expiration date. That lock means that your browser has successfully verified the site identity using PKI. PKI is public key infrastructure, and confirming that you are talking to the real platform and not a malicious hacker clone, right? And what is public key infrastructure? It is a complete system, complete hardware, software, people which are required to create, manage and distribute and revoke digital certificate and public key encryption. So what happens in public key is that it act as a police, I would say, right? So it components are certificate authority, which are trusted entity that issue the digital certificate. Then we have registration authority. It verifies the identity of requesting certificate before the CA issues them. There is certificate repository. So it is a database where all the certificates are stored and can be verified. And there is a revocation list, which are the list of a certificate that had been cancelled before their expiry. For example, if a company's private key is stolen, then we revoke that particular certificate, right? So it will go in a revocation list because that company's certificate was cancelled before their expiry date and the reason was stolen, right? So this is the public key infrastructure. So let's discuss about in real transaction. E-commerce network deploy a brilliant hybrid system during this will talk about SSL handshake to capture the absolute best of both worlds. So what is the handshake? That your browser navigates to an electro hub and uses slow, secure, asymmetric public key encryption to verify the site's digital certificate identity via PKI. Then there is a key exchange. So once the identity is fully verified, your browser generates a temporary single-use symmetric session key, that is secret key, and encrypts it using a server public key and fires it back. And then there is a secure session. The server decrypts it using its hidden private key. So for the reason of your shopping journey, the platform switches entirely to symmetric encryption because it is incredibly fast. It is allowing product catalogs and images to load instantly while keeping your checkout data 100% secure. I hope you understood this. Let's move forward and discuss about how should we secure our channels. Right. So to protect an online exchange of value, encryption data file isn't enough. The entire communication channel must be hardened. So this means creating a secure cryptographic tunnel across the web so that the data packets can move safely between the client and the merchant. So to make sure, we have foundational network tools, right? First is the SSL. So you have been hearing this throughout the journey, what SSL is. It stands for Secure Socket Layer. So SSL is developed originally by Netscape, okay, and it is this was a foundational protocol built to carry private documents over the web. Okay, so it was built to carry private documents over the web. However, write this down, okay, as a critical academic note, that original SSL protocol are completely deprecated today. Okay, so you need to make this sure that you write this down, that original protocol of SSL is deprecated. Okay, it is not used anymore due to the critical security vulnerabilities that it had. That is why the SSL is replaced by TSL. Okay, TLS. So we'll discuss what that is. So how does SSL work? It uses the combination of public key and the secret key encryption and provide a padlock icon in your web browser. Okay, but it has been replaced by TLS. So what is TLS? TLS stands for Transport Layer Security. So in this modern highly secure environment, the successor to SSL is TSL. When an e-commerce company purchases an SSL certificate today, they are actually deploying TLS underneath. Okay, so it handles the handshake, it checks the data integrity and ensure complete confidentiality across the web. All right, so there is it works the handshake properly. So there is a negotiation where client and server agrees on which server version of TLS and which encryption algorithm to use. Then there is authentication where the server sends a digital certificate to the client and client verifies it via PKI. And then there is the key exchange where the secure session key is generated to encrypt all the data during the shopping session. So the TLS ensures that there is data integrity, that data isn't changed during transit and confidentiality is maintained. That means that hacker cannot sniff any kind of information of payment transactions or card details. Then comes the difference between SSL and VPN. So what does VPN means? Let's discuss that first. So while SSL and TLS secure the connection to a specific website, VPN secure the entire internet connection of a device. Right, so a VPN encrypt all network traffic across your entire device. It uses an advanced tunneling protocol to mask your IP address completely. So think about your professional work inside an organization. So when you're working remotely from a public cafe, a hacker sitting on the same open public Wi-Fi network can easily sniff your traffic. But if you launch an enterprise VPN, if you launch a virtual private network, so it encrypts all the network traffic across your entire device. It uses an advanced tunneling protocol and it masks your IP address completely. Right, so it builds a private tunnel, right? So it will shield all the internal database query system files from the external eyes. So if any other hacker is sitting in the same public network, they cannot identify your packets. Okay, so let's look at the summary chart of the difference of SSL and VPN. So if we talk about SSL, it is an application bound. It secures the single dedicated connection stream like HTTPS browser tab, right? It secures single application. Whereas VPN is device bound. That means it secure every single byte of incoming and outgoing network traffic across the entire machine. Right? And SSL is completely automated. It triggers silently the moment a user lands on HTTPS website. And VPN, it demands a dedicated client application or software to be actively running on the machine. So the client have to activate the VPN and then they can use it. And if we talk about the primary commerce role, So the public customer conversion environments are provided by SSLs, but VPN primary use is to provide remote work safely, to secure the B2B database configuration and absolute privacy. And if we talk about implementation, it is handled directly at the application layer of the OSI model. So you have seen the network model of operating system. So the application layer is where SSL or TSL is implemented, whereas VPN is handled down at the network or transport layer of the communication. Alright team, now we'll talk about absolute grand finale of our network defense module, and this is a very straightforward topic, that parameter security technologies to use to secure the network. In our last section, we discovered how SSL, TLS and VPNs are built an encrypted secure tunnel to protect the data while it's moving across the web. But what happens when an attacker tries to attack your core infrastructure directly? What keeps the hacker from breaking straight into your web server and copying your entire credit card database? So to protect your enterprise, you need to establish a multi-layer parameter defense system. So think of your e-commerce platform like a high security medieval castle. So you don't just put a lock on the treasury door, right? You build a massive outer wall, dig a deep moat and station out lookouts and put an armed guards inside the corridors, right? So let's break down these 4 critical security systems with real world examples. First, we'll talk about the firewalls. Firewall is also known as the gatekeeper, or you can say it is the castle drawbridge. So you see there is all water filled around the castle, and there is just one bridge that is connecting the other land to the castle, right? So this is what firewall does. It is a dedicated network security system that monitors, filters and control incoming and outgoing network traffic, right, on a predetermined security rules. So think of a standard firewall as a security guard that is standing at a castle drawbridge with a guest checklist. So the guard looks at every single data packet trying to pass through it and check its port number. So this is known as packet filtering, where every packet is checked, right? So for our premium electronic store, consider Electro Hub, right? Our firewall rulebook states that allow all the traffic from port 80, that is HTTP, and port 443, that is HTTPS. So customer can see our website storefront and buy gadgets. But the second the hacker tries to send even a single packet, right, to send a malicious data packet via, for example, port 23 telnet, to gain silent remote access to our operating system, the firewall checks it, the rule, sees the port number, and it is blacklisted and drops the packet immediately, right? So what has happened, we have to mention that we use web application firewall. So it is a standard network firewall that looks a packet address and port number. So web application firewall is highly specialized e-commerce firewall that looks deep inside the actual application data payload to identify and block common application layer cyber crimes, such as SQL injection, or there is cross-site scripting. So it ensures that if a malicious user types a harmful database command into your site search bar, the web application firewall neutralizes the input before it even touches your core database layer. Next, we'll discuss about proxy servers. Okay, so what is a proxy server? Moving past the gatekeeper, we reach our second parameter, that is proxy server. So a proxy server acts as a structural intermediary or a middleman between the client web browser and your internal corporate server. So to understand the proxy server, you need to think of it as a celebrity's personal assistant. or a royal body double. So when the public wants to ask a question, they don't talk directly to the celebrity. They hand their letter to the assistant, and assistant walks backstage, gets the answer, and hand it back. So this architecture solves three massive commercial e-commerce challenges, right? So you see over here how proxy works. What is happening over here? This is our website and this is the proxy server. So whenever there is anything, any request or data packet that is coming, first it is checked by firewall. After the firewall, it is sent to the proxy server. The proxy server checks it if it is reliable to be sent to the website or not. If it is, then it sends to the website, right? So what issue it solves? Because the public only ever interacts with the proxy server public facing interface, right? So the true internal IP address of your core web and database server are hidden behind the enterprise firewall. So hacker cannot attack a target they cannot see, right? So our hidden actual web and database server will be safe. So there will be neutralized IP spoofing. There cannot happen, right? Also, it stores the copy of frequently accessed product pages. So when a new user requests that page, proxy serves it, right? So this is faster and it improves the site speed and SEO as well. And there is anonymity and filtering. So for a company's internal staff, like your role handling property codes, right, in a particular company, so an internal proxy can be configured to monitor and block employees from accessing dangerous or malicious external website. So this can prevent data sniffing malware from slipping it into the corporate network. So proxy server help in this as well. So next we'll discuss about highly popular question, that what is the exact difference between IDS and IPS. So first let's completely clear what exactly they are. So think of IDS as intrusion detection system, as a security camera network that is installed throughout your castle corridor, right? So it sits passively, continuously scanning all the network traffic loops, looking at distinct signatures or behavior patterns of known cyber attack. The second it spots the attacker attempting any brute force entry, so what IDS does, it rings an alarm and fires an immediate critical alert to the system administrator dashboard, and it detects the threat, but it cannot stop it on its own. So since it is a detection system, we need something that prevents it, that protects it. That is why we have IPS. IPS stands for intrusion prevention system. So after the detection, this is where IPS steps in. So think of IPS as an active armed security guard. So IPS sits directly in the line with your network traffic. It doesn't just sound the alarm when the threat is identified. It takes immediate defensive action. Okay, so for example, if a massive DDoS botnet attack hit the Electro Hub, flooding our network infrastructure with millions of fake traffic packets, like IPS detects the an IPS detects the malicious signature pattern and triggers an automatic defensive override and drops the specific corrupted packet instantly to keep our website online, stable and responsive. So crucially, the modern IDPS and IPS framework do not just rely on matching old known signatures. They use advanced heuristics. Okay, so they use that to which is AI driven behavior analysis engine, and it observes the normal baseline behavior of your network and can spot if there is any brand new unknown threats based on unusual weird movement that a simple firewall would not miss completely. So there can be few things that can be missed by firewall and proxy server, right? But if we have an advanced intrusion detection and protection system, it cannot be missed here, right? And then comes the antivirus. This is the health monitor. We all know what standard antivirus software does on our personal laptop, right? But in an enterprise e-commerce architecture, antivirus software must be installed natively at your core web server and database server to act as a continuous health monitor, to ensuring that data assets are never corrupted or leaked by malware like trojans or worms. So imagine your store, Electro Hub, launches a highly interactive feature where customers can upload a custom graphic photo to print onto the personalized tech accessory order. So if a malicious hacker tries to exploit this upload window by hiding a descriptive script virus inside the standard like .jpg file wrapper, our server side antivirus engine intercepts the file in real time. It runs a deep signature scan across the payload data before it saves to our database or execute on our network. Okay, so it catches the malware, it quarantines the file and blocks the attack. So to keep this defense system operational against the latest cyber threats, the antivirus engine must run constant. Okay, and it must be automated. So there are signature definition updates which are directly from global security centers to ensure that it can neutralize modern malware strains instantly. That is why it is very important to have antivirus software in our enterprise level e-commerce. Alright, guys, we have officially crossed the final finish line of this complete comprehensive one shot masterclass of e-commerce. Congratulations. So, before you close this tab and head out, let me know in the comments below, are you able to understand the concepts or not, or if there is any feedback you have for me. If this deep dive guide helped you wrap your head around all the terms, hit that like button, subscribe to the channel, and share this video with your classmates and help them master with prep too. Thank you so much for learning with us today. Rest up, stay focused, write confidently, and go ace your exam. We believe in you, and we'll see you in the very next masterclass right here on Padhai Logic. Bye for now. All the absolute best for your exam.